All right, so let's notice some differences between example 3 and example 2 before we dive on in. So example 3, you'll notice now we've been given the first derivative, which is nice and factored for us. Thank you very much. And we're being asked to find our intervals of increasing for the original function, g, right? So note, we're going to use that to find our increasing and decreasing intervals and the location of any relative extrema. Little different than 2. 2 just said find any relative extrema. So this different, we had to find the derivative, we had to do all that work, but also the finding the relative extrema meant that we should have gone further. And I did when I got to Desmos, but I didn't write it into my actual work for this problem. We should have gone ahead and said, well, f of negative 2 is equal to, and then put in that value of negative 8.33, or really we know that's negative 8 1/3. Nobody writes mixed numbers, but it's okay. And we could have done that and said, okay, here is the relative minimum. It occurs at x is equal to negative 2. But let's go ahead and just tackle 3, knowing that I won't have to plug in any values to the original function, which also makes sense because we don't have the original function here. So all we can do is say where those max or mins happen. Okay, so no need to take a derivative. We're going straight to our critical values. Again, we're in polynomial land, so no worry about whether or not this thing will ever be undefined, only setting equal to 0. And we can use our zero factor property since it's already factored for us. We have x is equal to 0, x is equal to negative 4, and x is equal to 5 as our critical values. Let's go ahead and make ourselves a beautiful plus minus table. I don't like how straight that line turned out. There you go. All right, negative 0, negative 4, and 5. Perfect. We can go ahead and just mark those with closed circles. We know we're going to include them in our intervals of increasing, decreasing, and they will be potentially our relative extrema. So let's think about this. Well, you know me, I don't love test values. I like being clever. So I'm going to think about what that leading term of this would be. So the leading term of this, my g prime of x, would be 3x to the fourth, right? We get the 3x squared times an x times an x. So I have a positive leading coefficient and an even degree, which means my end of this function is going to go like that. It's going to open up just like a parabola would. So I already know some stuff. We're positive here. We're positive here. I also can look at my zeros and notice their multiplicity, right? This is even, so we're going to get a bounce. We're not going to have a sign change. This is odd. It has a degree of 1, so we'll cross our x-axis, and we have another odd for a cross with another degree of 1. So at negative 4, where I was, I'm going to come to negative 4, and I'm going to cross that x-axis because I have an odd degree. So I am now in negative land. Okay. I'm going to keep coming over here to 0. 0 is even though, so we're going to bounce. So we stay negative. And we keep coming over to this 5. There we're going to cross again, and we already said that it was going to be positive over on that side. So it kind of gives us a confirmation if we start by end behavior and use our multiplicities to fill in this table, we get that little like pat on the back that we did everything right. So there we go. And of course, if you really want to, you can plug in a test value and see what happens. There's never a reason you can't just do both, right? But here we are. So let's go ahead. We could say, let's do the increasing. Our increasing intervals are negative infinity up to negative 4, and really technically or, from 5 to infinity. Cute. Our decreasing interval, since 0 is allowed by the definition, is from negative 4 to 5. If you disagree, then of course you have to put the union notation and have that 0 with the parentheses. And then we could talk about our extrema. So it looks like we went from, let's just quickly do this, positive to negative at 4. So negative 4 is a max. We'll have, oop, come on, you can write. We'll have a local max at x is equal to 4. And that's because Our f prime is going from a positive to a negative, right? And then we come over here. 0 is nothing. It was decreasing and now it's still decreasing. Nothing happened there, nothing to talk about. But for 5, we were decreasing and then we started to increase. So we have a local min or a relative min. I keep switching back and forth at x is equal to 5. So that's it. We get everything at once with this beautiful problem where they've given us a factored, my goodness, derivative, first derivative of our function. So we get intervals of increasing, decreasing, and our relative extrema all for the price of 1.